Let's use trig functions in order to solve for missing lengths. So here we have to solve for x. So in order to do this problem, I'm first going to identify my reference angle, and here we have 74 degrees. Next, I'm going to begin to label my triangle. So here, I see that the length that's across or opposite of my angle of reference is going to get labeled as the opposite side. The length that's across the 90-degree angle, that one is going to get labeled as the hypotenuse. And by process of elimination, the final side has to be called the adjacent side, but I'm not going to label it since I don't have any information on it. Next, I'm going to make use of my acronym SOHCAHTOA. I'm trying to find x, so I'm going to use these two values, 12 and my variable. And I notice that I have the O and I have the H, and the only trig function that makes use of O and H is sine. So here I'm going to have to apply sine of my angle of reference. Here it's not theta, it's 74 degrees. So sine of 74 degrees is going to equal the ratio of opposite over hypotenuse. My opposite side is x, my hypotenuse is 12, so we get x over 12. So I have this equation right here. I have sine of 74 degrees. That's going to equal x over 12. And now I'm going to do something clever. I'm going to divide sine of 74 by 1, because dividing by 1 is not going to change the value of this expression. And here's the reason why I'm doing it. Because now I have a proportion. And remember, when we have a proportion, we have two ratios equaling each other. And better, whenever we have a proportion, we can apply cross multiplication. So I'm going to do 12 times sine of 74. So 12 times sine of 74, that's going to equal 1 times x. And now we can solve this equation. 12 times sine of 74 is going to be 12 sine 74. And then 1 times x, that's just x. X is already isolated in this problem, so all we have to do is simplify the left. And we can do that by just inputting this in the calculator just as is, 12, and then there's a sine function. Click sine, put 74, and then close it with parentheses. You can also do this in decimals. So let's go ahead and approximate this, and I'm getting an approximation of, so x is approximately 11.54, rounding to the nearest hundredth. For these problems, I want you to give me both of them. Because maybe you're not inputting it correctly in the calculator, but at least I'm going to know that you're following the correct steps, and then I can help you on how to get to this part. Alright, let's do one more example. Let's try this one now. So first things first, we got to identify our angle of reference, and here it's 50 degrees. So now let's begin to label it. So we can see here that the opposite side, we don't have any useful information, so I'm not going to go ahead and name it. Instead, I'm going to look at the side that's across my 90-degree angle. So here, I have useful information. This one's called the hypotenuse. And this one should have been the opposite side, which leads us to claim that x is the adjacent side. Let's bring up our useful acronyms, SOHCAHTOA. And here, for this problem, we're going to have to make use of a and h. And the only trigonometric function that uses a and h simultaneously is cosine. So we're going to use the cosine function this time. So we're going to get cosine of our angle of reference. In this scenario, it's 50 degrees. So cosine of 50 degrees is the ratio of the adjacent side over the hypotenuse. So a over h. The adjacent side, a, is going to be x. The hypotenuse h is 20, so we're going to get we're gonna get x over 20. And now we have this equation, cosine of 50 degrees is equal to x over 20. And just like last time, I'm going to divide cosine of 50 by 1 so I can get a proportion. And now I'm going to apply cross multiplication. 20 times cosine of 50 degrees, that's going to be 1 times x, which is just x. So here there's nothing to do other than to simplify the left hand side. In some of the problems you may be required to do a little bit more algebra in order to isolate x, but here this comes out pretty clean. So inputting this in the calculator, I'm getting an approximation of, let's check it out, 17? Hold on. So I'm getting an approximation of 12.86. And there you have it.